Hey YouTube, this is Brendan with Cusack Prep, and in this video we're going to be discussing how to graph transformations. Now, graphing transformations is something that is a little bit confusing and it's a little bit hard to explain via YouTube, but I'm going to do the best that I can here. So what a transformation is it's just some kind of shift of a graph, and this shift could be to the right, it could be up, it could be left, could be down, could be stretching vertically, stretching horizontally, as well as compressing in those directions. And we want to kind of show you what you have to look at from an equation to see what transformation is taking place. So I'm going to start with what you call a parent function. A parent function is just a standard function that your graph is going to start from. So an example of a parent function is something like y equals x squared. Now I'm just going to sketch this very roughly so you can see what I'm referring to and see what this looks like. So y equals x squared is going to look something like that. So just kind of a rough sketch. Now the first type of transformation that we're going to talk about is a transformation that shifts up or down, also called a vertical shift. Now, vertical shifts take place when you add something to or subtract something from the parent function. So examples of vertical shifts might be something like y equals x squared plus 4, y equals x squared minus 3, something like that. And with the vertical shifts, it kind of makes sense. You'll see what I mean when it doesn't make sense in a minute. So what would happen here is the shift would be up 4 units. And what would happen here is the shift would be down 3 units. So that kind of makes sense, right? If you're adding, you think you're going to be moving up. If you're subtracting, you think you're going to be moving down. So a quick sketch, or just a rough sketch, of these graphs might look something like this. So it's going to move up 4 units, and it'll do something like that. Or in this case, it's moved down 3 units. And, it's going to do something like that. So it really kind of keeps the same general shape, but it's been shifted up or it's been shifted down. And that's what you call a vertical shift, or a vertical translation. It can really go by a couple of different names. But essentially we're just moving the graph up or down. Now we're going to contrast that with what you call a horizontal translation. And horizontal translations are a little bit counterintuitive. They don't always do what you think they're going to do. So we got a horizontal translation. So the way horizontal translations work is instead of it being added on to the function at the end, you're replacing x with something. What I mean by that is instead of y equals x squared, maybe I have y equals x minus 2 squared. So the x has been replaced with x minus 2. Anytime you have parentheses and something being added or multiplied by the x inside of those parentheses, it's usually going to be the case that it's a horizontal translation. And how I said vertical translation makes sense, horizontal translations don't. They just kind of do the opposite. So plus 4 meant up 4. Well, if you think of minus 2, you usually think of going to the left. However, x minus 2 is going to be shifted right 2 units. So it's the opposite of what you think it would be. And then if we had something like y equals x plus 3 squared, well, that one's going to be left 3 units. So going from the parent function, I'm going to be drawing a graph that is shifted to the right 2 units. So instead of cutting through the origin, it's going to cut through this point here. And a graph that's going left 3 units is going to be going this way here. And that's how you deal with translations. Now, this doesn't just apply to something like x squared, but it really applies for almost any of the normal functions. A logarithm function can be shifted up or down. A square root function can be shifted up, down, left, right. A exponential function, they can have all the same shifts, and it's really the same rules. You just have to look at, are you adding something to the parent function and subtracting it from the parent function? Or are you simply replacing x with something else? Now let's talk about vertical stretches. So a vertical stretch happens when you multiply the function by something. So let's again kind of have our parent function y equals x squared. And we're going to have a vertical stretch on the function y equals 3x squared. Now, graphically, what this is going to look like is y equals x squared is going to be just a pretty standard parabola. Plot some points on it, 0, 0, 1, 1, also goes through the point 2, 4. So let's say that those are what those points are. So that's negative 1, 1, that's 1, 1, that's 2, 4. It's negative 2, 4. Now, vertical stretch of 3 just means I'm taking the graph and I'm like stretching it out. So just imagine you have a t-shirt and you're trying to make it longer. You're going to stretch it. And since it's vertical, it's going to be stretched up or down. So what happens with this 3x squared is it takes all of the y coordinates and it multiplies them by 3. So instead of the point negative 1, 1, we're now going to have the point negative 1, 3. Instead of the point negative 2, 4, it's going to be up here somewhere, kind of off of the graph as I've drawn it. But it just creates a much more narrow looking graph. This graph looks thinner. And that's what a vertical stretch does. Now, this is going to be my red line. This is going to be my blue line. And then I'll use a different color here to show you if you have a fraction. So let's say we had something like y equals 1/2 x squared. Well, I've seen this kind of written a couple different ways. You can call it a vertical compression because you're multiplying by half, so it's going to go down. Or you can call it a vertical stretch by a factor of 1/2, so it's stretching, but because it's a fraction, it's being compressed. So what happens here is we're going to have to kind of extend it out. So instead of the point negative 1, 1, we have the point negative 1, 1/2. Instead of the point 2, 4, we have the point 2, 2 and negative 2, 2. So it's going to look something like that. So you can see that it's kind of become compressed. Just imagine you had these lines and you pushed down on them and they went out a little bit wider as they went down, and so it just looks compressed. And then we'll take a look at what you call horizontal stretches. So a horizontal stretch, just like before when we had our horizontal translations, they're going to be a little bit counterintuitive. They're going to be kind of the opposite of what you think they are. So if I have something like y equals x squared as my parent function, actually let's do a different one. We've done a lot of these. Let's say I had something like y equals, let's do the square root of x. Well, a horizontal stretch is going to take place when you're replacing x with something else. So let's say we had something like y equals the square root of 2x. Now, just like before, it's a little bit counterintuitive. So you think if you're multiplying x by 2, you want to do this. You want to expand it out. But that's not what happens here. When you multiply x by 2, you're actually compressing it. So this would be a horizontal compression of 2, or a horizontal stretch of 1/2. So it's the opposite. Just like plus 3 was left 3, it didn't really make any sense. I'm going to call this a horizontal, we'll call it a compression. 1/2 to, really your teacher will be very specific with the wording. And then on the other hand, if I had something like y equals the square root of x over 3, that's going to be a horizontal stretch by a factor of 3. So the key thing to really remember is it's just the opposite of what you think it is. So we can just kind of sketch a quick graph of what these would look like. So square root of x starts at the point 0, 0, 1, 1, 2, 4, 8, 0.93. So it just kind of looks something like this. So that's not a great curve, but I think you get the idea. And then a horizontal compression of 1/2 means everything's going to be shrunk this way. So instead of our point being there, it's going to be halfway closer to the y-axis, there, and there. So the compression looks like this. Essentially, every point on the graph has been compressed by half. And then this horizontal stretch of 3, instead of the 0.11, we're going to have the 0.31. This and that, and you can just kind of see it looks a little bit like that. And then finally, the last thing you really have to deal with are negatives. So if I put let's do this down here, if I put a negative in front, so let's say I have my parent function as y equals x squared, and I go ahead and I turn that into y equals, so let's do the square root of x again, square root of x, and I do y equals the negative root x. Well, when the negative's in front, it's going to make your y coordinate negative, so it's going to flip it over the x-axis. On the other hand, if you put your negative on the inside, like this, and you have the square root of negative x, that's going to flip it over your y-axis. So let's go ahead and draw that. So the square root of x is going to do something like that. When I have the negative in front, it's flipped over the x-axis, so it's going to look something like this. I'll just note that that's that one. And if I flip it over the y-axis, it's going to reflect something like that. And so that's a basic intro into the transformations that can take place. In this example, we mainly used x squared as well as the square root of x. But really, you can almost do it with any function. Just remember the basic rules of how things shift, how they stretch, and how they flip. And you should be able to apply this to most concepts. Thank you for watching.